Balancing a pencil or any other top-heavy object on its tip is quite a precarious task.
It's easy to see why top-heavy objects are unstable. They just want to fall down.
Any little nudge will put it off balance, with gravity happy to pull its center of mass even more off balance, and the more off balance it is, the more gravity pulls until... Physicists call this kind of tipping an inverted pendulum, because it's kind of like an upside-down pendulum, and careful mathematical analysis of inverted pendulums will tell you the obvious. They're really unstable. In fact, these equations predict that if a perfectly balanced pencil with a perfectly sharp tip were to get nudged off balance by just 1/10,000th the width of an atom, it would take only 3 seconds to fall over. There are indeed acrobats who can balance poles with other acrobats on top, and robots that can balance and catch and throw upright sticks, and people who make seemingly impossible artistic rock stacks. But in all these cases, keeping the objects balanced either requires an active stabilization effort, or else carefully taking advantage of the fact that the balancing point isn't actually a point. So the question is this: can you balance a pencil sharpened to a perfect single atom wide tip on its tip without active stabilization? Well, to start, you'd better get rid of all the air bumping off the sides of the pencil, since the kinetic energy of a typical oxygen molecule is enough to destabilize the pencil. Remember, if the pencil gets off-center by even 1/10,000th the width of an atom, it'll fall down in under 3 seconds. And you'd better cool the pencil and table down as close to absolute zero as you can, since the thermal jiggling of their atoms when they're hotter will similarly jiggle the pencil off balance. But even then, matter at very small scales has a spread-out wave-like nature, which means you can't have both the pencil perfectly upright and not moving at the same time. And while this quantum effect is never a real-life inhibitor of precarious pencil balancing, it means you never even could succeed. However, it's still fun to see how long you can keep a pencil balanced on your fingertip. The shorter the pencil, the harder it is. My best time for a standard 19cm pencil was 1.3 seconds. Think you can beat it?
This Minute Physics video was brought to you by Audible.com, one of the leading providers of online audiobooks across all types of media, including fiction, nonfiction, and periodicals. I'd like to recommend The Tipping Point by Malcolm Gladwell this week. It's a book about kind of exponential increases and spreads of trends, social trends, epidemics, that sort of thing. And the mathematics is somewhat related to the mathematics of balancing an object on its tip. So anyway, The Tipping Point by Malcolm Gladwell. Audible.com supports Minute Physics, and without them, we wouldn't be able to do what we do. So thank you to Audible, and head to audible.com/minutephysics to get your free audiobook.